Hey everybody, Jamal here. Solar inverters are the brains of your solar power system. Sometimes things go sideways. Today, we're diving into the top 10 solar inverter faults and how to fix them. Because who wants to be left in the dark? This video's got something for everyone. Smash that subscribe button for more tech tips. Alright, so you go to check your solar setup and the inverter's deader than a doornail. First things first, don't panic, we've all been there. More often than not, it's something simple, like a loose connection or a tripped breaker. So before you go tearing your hair out, let's start with the basics. First, make sure your inverter is actually getting power. Check that it's plugged in properly and that the outlet or breaker supplying power to the inverter is actually on. If you're running off batteries, make sure they're connected and charged. Next up, look for a power switch on the inverter itself. Give it a flip and see if that brings your inverter back from the dead. If you're still not seeing any signs of life, it's time to grab your trusty multimeter and check the voltage at the inverter's input terminals. So, you've got power at the inverter, but it's still giving you the silent treatment. Well, it's time to channel your inner detective and investigate the input voltage and frequency. Solar inverters can be a bit picky about the electricity they're fed. If the voltage or frequency is outside of the inverter's comfort zone, it's going to throw a fit and shut down. First things first, grab your inverter's manual. It's your best friend when troubleshooting. Look for the section that talks about the inverter's acceptable input voltage and frequency range. Now, with your multimeter set to AC voltage and frequency, carefully measure the voltage and frequency at the inverter's input terminals. Compare these readings to the acceptable range specified in the manual. If the voltage is too high or too low, or if the frequency is out of whack, you've found your culprit. Low voltage is a common problem, especially if you're running long cable runs from your solar panels or batteries. Okay, so your inverter is still MIA, and you've checked the power source and input voltage. Time to investigate those little safety devices that often get overlooked: fuses and breakers. These guys are like the bodyguards of your electrical system, always ready to take a bullet for your expensive equipment. To check your fuses, locate the fuse holder on your inverter. Carefully remove the fuse and inspect it visually. A blown fuse will have a visible break in the metal filament inside. If the fuse looks good, use your multimeter to check for continuity. Breakers, on the other hand, can usually be reset. Locate the breaker panel for your solar system and look for any tripped breakers. To reset a tripped breaker, switch it fully to the off position and then switch it back to the on position. If the breaker trips again immediately, you've got a more serious electrical fault that needs to be addressed by a qualified electrician. Always replace fuses with ones that have the same amperage rating as the original. Alright, if you've made it this far and your inverter is still throwing a tantrum, it's time to break out your inner electrician and double-check those connections. Trust me, even the most experienced installers can make a mistake now and then. Loose connections, crossed wires, or even using the wrong type of wire can lead to a world of headaches. First up, grab your trusty manual once again and familiarize yourself with the wiring diagram for your specific inverter model. Pay close attention to the polarity of the connections, especially when dealing with DC wiring from your solar panels and batteries. Now, with the wiring diagram in hand, carefully inspect each connection at the inverter. Make sure the wires are securely fastened to the terminals and that there are no loose strands that could cause a short circuit. While you're at it, check the condition of the wires themselves. Look for any signs of damage, such as cuts, abrasions, or melted insulation. If you've recently moved your inverter or made any changes to your wiring, double-check that all the connections are still secure. Vibrations from heavy machinery or even just regular operation can loosen connections over time. Checked everything. Power source, input voltage, fuses, breakers, and connections? Still no power output? Time to interrogate the inverter itself. Ensure it's on and check for error codes. Consult the manual for error codes. Verify the load isn't overloading the inverter. Still no output? Use a multimeter. If voltage is off, call a qualified technician. Alright, so you're running an off-grid or hybrid solar system with battery backup, and your inverter seems to be acting up. One possible culprit you might encounter is a battery full condition. When your solar panels are generating more power than you're consuming, the excess energy gets stored in your batteries. But batteries have a limited capacity. Overfilling them can lead to damage, reduce their lifespan, or even create a safety hazard. Most charge controllers and inverters have built-in safety mechanisms that stop charging the batteries once they reach a certain voltage. If you're consistently seeing a battery full message, even when your energy consumption is high, consult with a qualified solar technician to diagnose and resolve the issue. Chapter 7. Decoding the cryptic fault codes 00009. Sometimes, your inverter will try to communicate with you through a series of flashing lights or cryptic codes on its display. These are like the secret handshake of the solar world, and understanding them can save you a lot of time and frustration. Every inverter manufacturer has its own language when it comes to fault codes. So, the first rule of troubleshooting fault codes is, grab your manual. Seriously, I can't stress this enough. The manual will have a dedicated section that deciphers those mysterious codes, telling you exactly what's going on with your inverter. For example, let's say your inverter is displaying fault code 3. A quick glance at the manual might reveal that this code indicates a ground fault detected. Armed with this knowledge, you can start investigating the grounding connections and wiring for any faults. Or you might see fault code 6 flashing on the display. The manual might tell you this means over-temperature protection activated. The point is, those fault codes aren't there to intimidate you. They're actually trying to help you by pointing you in the right direction. Alright, we've covered a lot of ground today, from basic troubleshooting tips to deciphering cryptic fault codes. But let's be real, sometimes, no matter how much you love tinkering with tech, there comes a point where you need to call in the cavalry. Knowing when to wave the white flag and bring in a professional is just as important as knowing how to troubleshoot basic problems yourself. If you've exhausted all the troubleshooting steps we've discussed, and your inverter is still giving you the silent treatment, it's probably time to call in a qualified solar technician. These guys and gals eat, sleep, and breathe solar power, and they have the experience and expertise to diagnose and repair complex inverter issues that are beyond the scope of the average DIY enthusiast. Remember, dealing with electricity can be dangerous, especially when dealing with high-voltage DC systems common in solar installations. Attempting to repair or modify your inverter without the proper knowledge and safety precautions can lead to serious injury or even death. Preventing solar inverter issues is key. Keep your inverter clean. Dust can cause overheating. Use a brush or vacuum to clean. Ensure proper ventilation. Avoid enclosed spaces. Consider temperature-controlled environments. Schedule regular inspections. So there you have it, folks. We've journeyed into the heart of solar inverter troubleshooting, demystified those cryptic fault codes, and armed you with the knowledge to keep your solar power system running smoothly. Remember, while inverters can seem intimidating at first, they're really just sophisticated pieces of technology designed to harness the power of the sun and provide you with clean, reliable energy. The key takeaway here is, don't be afraid to get your hands dirty and explore your solar system. Familiarize yourself with your inverter's manual, learn how to interpret those error codes, and embrace the troubleshooting process. You might be surprised at how much you can diagnose and fix yourself with a little bit of knowledge and a can-do attitude. Of course, safety should always be your top priority. If you're ever unsure about something, or if you encounter a problem that seems beyond your comfort level, don't hesitate to call in a qualified solar technician. Now go forth, solar warriors, and conquer those inverter challenges. Well, folks, that was a deep dive into the world of solar inverters. Hopefully you found this video helpful and maybe even learned a trick or two. Remember, a little knowledge can go a long way when it comes to troubleshooting tech and keeping your solar power system running smoothly. If you enjoyed this video and want to see more tech deep dives, troubleshooting tips, and maybe even a few explosions, just kidding, maybe, make sure you hit that subscribe button and ring that notification bell so you don't miss out on any future uploads. And hey, If you've got any questions, comments, or maybe even some inverter horror stories you want to share, drop them in the comment section below. I love hearing from you guys. Until next time, stay curious, stay empowered, and keep those solar panels shining.